Hey guys, Mr. H with A-Level Tech here. Okay, we're going to talk about some of these hydraulic brake equations that we have going on. I'm going to try to break this down as best as I can. The reason why I'm making this short video is for those of you who are trying to understand or grasp the different formulas and stuff like that. You can pause this video, rewind it at any given point in time, and try to catch up as far as understanding how we're going to go through all of these steps to get these 6 answers. Another thing, I want to apologize right up front if you hear any noises, because it is pretty hot up here in at my place right now, and I have the windows open so you can hear the traffic of 230 going through Mount Joy. So if you hear anything, big rigs, sport bikes, whatever it is, I apologize. I'll try to talk as loud as I can so it kind of drowns it out. But anyway, let's talk about what we have going on here. So the first thing is I'm going to actually be working upside down so you guys can actually see this. So forgive me if it's a little trippy when we're looking at these. But you will have at your disposal the main rules and how to work through these problems to solve each one of these questions. Make sure you follow the order of these steps as you go through, as far as trying to find out what the pressure is. So you see we have force over area, or if you're trying to find out, let's say pressure, so force over area, or if you're trying to find force, it's pressure times the area. Make sure you follow these steps, especially the ones where it talks about when to round off to the nearest hundredth place. It won't say it till the very end, so that's something that can mess up or skew some of your answers as you go through here. But anyway, let's look at what they want for this mathematical problem. So the questions that they want answered is A through F, which is how much hydraulic pressure is created in the system, how much braking force is from the front brakes, how much braking force is from the rear brakes, and also how much total force is being applied to the master cylinder. And notice here it says round off to the nearest hundredth. So that's 2 places past the decimal point. So you can round off then. And then the last 2 is what effect does the metering valve have on the brake system, and what effect does the proportioning valve have on the system. We're going to ignore these last 2 until we get partial way through. But when you're reading through the helper cheat sheet for the formulas, you're going to notice the first thing it's going to ask, and I have a separate sheet over here, so it's not like I'm actually reading upside down. But first thing it's going to say to do is convert all of these fractions to decimals. So any of the fractions you see here on the information they provide for you, so whether it's, the caliper bore size is 3 3/8 or 15/16 or 7/8, any of these fractions, the first thing you're going to do is turn them into a decimal. So all you're going to need to actually accomplish these word problems is to, hang on, I guess I should make sure I'm recording. Oh yeah, I am recording. How about that? Okay, but all you're going to need is just a simple pocket calculator to do this. So first things first is 3 3/8. 3 by itself is already a whole number, so you don't have to worry about it. But for 3/8, turning that into a decimal is just 3 divided by 8. And that's going to give us 0.375. So the first thing I'm going to do is I'm actually going to make notes. I always want to see you guys show your work. So what we're going to do is write 3, because we already have the whole number, and 3/8. Now that is going to be 3 and 3/7/5. Now, that's a start. Let's just finish off through the rest now, okay? So let's try 15/16. So all I have to do is 15 divided by 16. And that gives me 0.9375. 0.3975. See, I'm not lying. It's true. You can double check me if you want. Okay, now the next one I have down here I see is, okay, we got 7/8 for the master cylinder bore. So 7 divided by 8. That's going to give us 0.875. 0.875. So there we go. All of our fractions are now converted into a decimal. Now, if you're reading into the sheet, what it does is it kind of walks you through what you want to do. So it walks you through on this cheat sheet, A through E. Okay, so the first one is convert the fractions to a decimal. Now we want to find the radius by dividing the diameter which is what they give you. This is the diameter, so 3 3/8, 15 16, 7/8, that's the diameter. They want you to find the radius of that. So the radius is half of the diameter. So now we're going to divide these numbers by half. Don't round them off yet. Don't do it. Don't do it. But now we're going to take 3.375 and we're going to divide by 2. So that's going to give us, and all I do is I kind of just write a comma and just write next to them. You can do it whatever way you want on scratch paper or whatever. But half of 3.375 would be 1.6875. And if you want, you don't have to follow my rules. If you want to just do all of this in just one elongated step, A through E, for each one, you can. But for right now, just for the purpose of going through, I'm going to put in each one. So now I'm going to move down to 0.9375, divide by 2. That's going to give me 0.4685. All right. And then last but not least, for that master cylinder, 0.875, divide by 2 to get the radius. So that's going to give me 0.4375. Okay. Now what? Well, now we got the radiuses of all these in decimal form. Now, if you read through, okay, so you have the radius, correct? Now you're going to want to square the radius. Square it. So we're going to take that number times itself. So just like when, back in the day, 9 squared, okay, 9 times 9, which is going to be 81, or whatever you might have. You're going to square that number. So now you're going to take those numbers we just divide by half and you're going to square them. So you're going to take those numbers and times them by themselves. So 1.6875. If you have a fancier calculator, you can just square it, but on the old school ones, you actually have to type it in. So times 1.6875. We're going to get that number. Yes, write that out. So we're going to get 2.8476562. Yay! And I already have a lot of these put out on scratch paper, so just to save time, I'll just tell you what these other ones are. This one's going to be 0.2197265. And then this one is going to be 0.1914062. So now we've gotten that far. So on this sheet, now we've gotten past this step, step C. So you're going to times it by itself. Now the next one is, now multiply your answer by pi. So if you guys remember what pi is, this is what we're going to use as pi. So pi is going to be 3.1416. Pi can go on for ever and ever, but we're just going to simplify it. So that's pi right there. So we're going to multiply these numbers now by pi. So once we get to that, once we multiply by pi, now we can round off the final number to the closest hundredth. That's step E. Once we get this number, then we can round off. Not yet, but after this we can round off. So like I said, I already have the work done, so I'm just going to kind of make this go just a little bit quicker. But if I were to take this, how would I want to say it by itself? Here, we'll do the first one at least, just so we actually, Mr. H is not cheating or lying to you. So 2.84765, and then 62 times 3.1416. That's going to give us that number. So 8.9461967. But we're going to round it to the hundredths place, right? So right here, this is my hundredths place, 4. I notice the next number is 6. That is over 5. So we can round this up to 8.95. And that's squared. So 8.95 squared, and that's going to be inches because that's what the original problem was. Now for these other ones, this is how it goes. So now you have for this one, 0.69 inches squared. And then for this one, this is going to be 0.60 inches squared. Just make sure you write these out correctly, though. The inches squared, you got to have that. So now that we have those numbers, now we can find out what we can do next. Now, so you can put that on scratch paper, you can put that wherever you want, just make sure you write these out. If you don't, I can guarantee at one point or another you might slip up and mess up. Gotta wait for that dump truck to go by. Alright, so now, what do we do after that? We've already rounded off. Now what we can do is we can actually go through and solve the equation. So what's next? Okay, let's take a look. So they want, the easiest one I'm going to say to go to right off the bat is E. So it's saying what effect, oh I'm sorry, not E, D. So let's go to D first, because D is a nice and easy question. So D, how much total force is being applied to the master cylinder piston, round off to the nearest hundredth? So here's what we're going to do. We're going to look at what the information is. So we know that the pedal ratio is 4:1. So our pedal ratio, so whatever our force is from the driver, it's going to be amplified times 4. So this means times 4, whatever the ratio is, whether it's 2:1, 3:1, 4:1, 5:1, it's going to be multiplied by that bigger number. So that's times floor. Floor. And now here they say the driver has exerted 94 pounds of force to the pedal. Notice it says pounds and then of force, not PSI. Make sure you read through these and get the answers correct as far as how you label them. So what you're going to do is 94 times 4. So if we do 94 times 4, you get 376. So for how much force is being applied, so from this person's putting 94 pounds of force to the pedal, which the pedal is going to be obviously attached to the master cylinder, not even worried about the vacuum booster, but that would be 376, oh, got another truck, pounds. So that's 376 pounds, not PSI, not pounds of force. Remember, it's already saying in force, it's just asking for how much. It's 376 pounds. Okay, now that we have that, this is the basis for using this for the rest of everything else that's going on. Now we can actually go up to A. So this is kind of the order I do them in. You can do whatever order you want, but overall you're still going to have to solve them kind of the same way. But now we go up to how much hydraulic pressure will be created in the system. How do we do that? Well, what we're going to do is we're going to take this 376 and we're going to go over to the master cylinder bore diameter. All right, now we're going to go over there. And what we're going to have to do now is we're going to have to take that bore size, and now we're going to have to translate that to actual system pressure. So this is going to be in PSI. So this one number is going to be in PSI. This will be system pressure. So coming from the master through the lines, whether it's going to, you know, the front, the rear, the metering valve, the proportioning valve, it's going to the lines. I'm trying to watch my time. I'm trying to not to make this video too long, because I understand it can be a little bit a daunting task doing these. But now we have to figure that out. So what do? Well, we look at our equation. What are we using here? They give us, we look up at what they give us here. We can fill in, just like in the electrical problems. Okay, I have the force. So here where they give you the formula, I have the force, which is 376. So I'm going to put in, just like that formula says, 376 over the area, which I already know is 0.60 inches squared. So now what I do is I'm going to take that 376 and I'm going to divide that by 0.60. And what I'm going to get is a number like this. So what I can say is that approximately, if I round off to the nearest hundredth like they say, my total system pressure will be 626.67 psi. So now I have those two numbers out of my equation. So from the foot pedal to the master going into the lines, now I have calculated that there's going to be 626.67 psi flowing through those brake lines in that system. Pretty cool, or maybe not. Depends on what you're looking at. Now, I can exit that out. Now, what else are they asking here? Now they're asking for the total front braking force to be produced and the total rear braking force. This is when we have to look at our system pressure and determine, does the metering valve do anything? Does the proportioning valve do anything? So in these steps right here between 5 and 6, they tell us the metering valve holds off operating range up to 125, and that would be PSI. By the way, I want to say that's PSI. Are we above that? We're at 626. Yes, we're above that. So the metering valve doesn't do jack squat. So we can say in here, you know, I want you guys to write more information on this, but right now we can say the metering valve does nothing. We've overcome that range, so it doesn't really do much of anything. Now, for the proportioning valve, up till 600, and then they say it has a slope of 50.50 or 50%. We're over 600, so yes, that does affect us with the metering valve. Let's take care of that first. Let's see what that means. Now, not the metering valve, the proportioning valve. Forgive me. So that's near the rear. That happens only when you're in a high pressure braking operation. In emergency, it keeps the rear from locking up. So what does that mean? A slope of 50? Okay, let's take 626.67, right? So I'm going to write that, 626.67, and they say 600, so let's just take 600 away. We're going to give it back, believe it or not. We're going to give 600 back, but right now let's take it away. So we're left with 26.67 psi. What do we do now? Believe it or not, at 50%, we're going to divide this 26.67 by 50%, which means if I divide this by 2, that's going to give me 13.335. Now guess what? That 600 I took away, I just added back in. So 613.335, or I could just say 0.3 if I want to. That's the number that's going to go to the rear brakes. So that's the PSI pressure. So system pressure is that much, but since we are in a higher braking application, the slope is 50%. So what it means is anything over 600 PSI, whatever that number is, you're going to half that. And that does that through the valving itself. We're going to half that. So it's over by 26.67, so you half that and you add it back in, so it's 613. So don't use the 626.67 to do the math for the front wheels and the rear. It's only for the front. The rear, we're going to take that number. Okay, let's see, where are we at? Time-wise, we're at 18 minutes. Man, this is going to be a long video, but you can fast forward, you can slow down at any given point in time. Okay, now, what are we going to do next? Now we're going to look at how much total braking force are the front brakes going to do. Here's something to look at before you mess this up. At the very end, make sure you multiply your numbers by how many pistons or wheel cylinder pistons you have. So notice in here, in 2, they say that the front brakes are slider type calipers with 1 piston per caliper or per wheel. What does that mean? That means for front brakes, you've got two pistons. So don't just write this number and then multiply and get your number and that's it. Remember, you got 2 calipers. That means if it's 1 piston per caliper, you technically got 2 pistons you got to account for. For drum brakes with wheel cylinders, look, each wheel cylinder has, I don't know why they drew a rotor on that one, but each wheel cylinder, you're going to have 2 pistons on each side. So for the rear, you're going to have to multiply it by 4. Makes sense, right? Okay, I know it's a lot of math, but it's still simple math using a calculator. It's just a lot of steps. Now, let's go off to, all right, now we have our PSI, right? So what do we need to do to get our, what are we asking for? Force. So they want the force. Like Luke Skywalker. So we want force. So what's force? That is, force is pressure times area. So we're no longer dividing, we're multiplying now. So pressure times area. So what we're going to do is we're going to take these numbers, we're going to multiply them by the pressure. So that 8.95 inches squared, we're going to multiply that by the 626.67. What is that going to give us? Let's find out. 8.95 times 626.67. That's going to give us 5,608. 6965. But remember, it's like Billy Mays, but wait, there's more. For front brakes, there's 2 pistons, right? So we're going to multiply that number by 2. So for the front brakes, how much force is being applied? Remember, not PSI. Force, that would be 11,000. 217, and then we're going to round off 39 pounds of force. So 11,217.39 pounds of force for the front brakes. Now for the rear, remember, we went through the proportioning valve and we decided that it's only going to be 613.33 PSI going to the rear. So now we do that with the rear brakes. So what we got for the surface area of the wheel cylinder, okay, that is 0.69. So, okay, 0.69 inches squared times 613.33. Okay, so that's 423.19 PSI. So we can change that to 0.20 later, but now we got to multiply that by 4 because there's 4 pistons, 2 per wheel cylinder. So multiply that by 4. That gives us 1,692.79, and we can leave that as 79. So the rear brakes, that is 1,692. And we'll just say 0.79. That's fine. Pounds of force. And then obviously for these two, you know, what effect did the proportioning valve have? Well, we can say that 0.5, or in other words, 50% affected that 626, or the 26.67, and turned it to that 13.35. So there you go. That is the math. Hopefully you can slow this video down. Hopefully you can pay attention to what steps I use to get these numbers. It is not very critical and daunting math. It's just knowing the right steps to solve the equation. But this is the basics. There's a lot more that actually goes into this, like brake booster and different effects. But we're talking about like the clamping force and things of that nature. This is the kind of formula you would use to figure this out. Good luck. I hope you guys do well on the task sheets and the homework.